Je vous propose d'ouvrir cette session technique en abordant le sujet de la disponibilité des ressources. Et je suis ravie d'accueillir, je ne le vois plus si je le vois, je suis ravie d'accueillir Abinash Ramasary, qui est cadre scientifique au Concawe en Belgique et qui veut nous partager donc, sa vision sur la disponibilité durable de la biomasse dans l'Union européenne à horizon 2050. Abinash, the floor is yours.
Great. Good morning, colleagues, and thanks for the opportunity to speak to you this morning. My name is Abinash Ramasary, and I am a science executive at Concawe. And the topic of my presentation this morning will be related to the availability of biomass resources in the EU up to 2050. As Florence has indicated, biomass resources are quite an important building block for the low-carbon energy transition. And one of the key questions that often arises is the availability of biomass resources, and this is something that I will elaborate on this morning. So maybe just to start off with a few words regarding Concawe, if you haven't heard about us, we are the scientific division of the European Fuel Manufacturers Association. This comprises approximately 40 member companies, which account for 95% of the European refining capacity, both of traditional fossil fuels as well as low-carbon fuels. Our mission is to undertake scientific research to support the energy transition, so both from a refining perspective, but also in terms of understanding the impact of our products on the broader economic cycle. One of the key areas of focus for us is understanding how refineries can support the energy transition, specifically understanding how can refineries support both the low-carbon energy transition as well as the transition of our conventional refining assets. The overview for the presentation that I will provide this morning covers different aspects. So the first one, I will provide an overview in terms of a study that was undertaken by us in 2021 related to the availability of biomass resources in the EU. This will be followed by a comparative evaluation of different biomass studies that were undertaken recently. And this will be followed by a discussion regarding the fuel outlook up to 2050 and whether biomass resources are sufficient to meet the forecasted fuel demand going up to 2050. And then lastly, I will end with some key takeaways from the discussion. All right. So to commence, I'd like to highlight an important study that was undertaken by Concawe that was commissioned by us for the Imperial College of London in 2021. And this was specifically looking at the availability of biomass resources in the EU. As part of the study, we considered a number of different biomass resources, and these were primarily focused on the then RED II regulations, covering both the Annex 9A and Annex 9B feedstocks. So what you'll see on the slide is just a list of the feedstocks that we evaluated as part of the study. These comprised of a number of different agricultural residues, forestry residues, as well as wastes as well. So in terms of agricultural residues, as you'll see, we consider different types of energy crops, primary agricultural residues, secondary agricultural residues, as well as manure. In terms of forestry resources, we considered here stemwood, primary forest residues, secondary forest residues as well. And then lastly, in terms of waste, we looked at a number of different waste products, which included food waste, vegetal waste, municipal solid waste, sewage, packaging, paper, and wood materials as well. And then lastly, in terms of Annex 9B, we also looked at the availability of used cooking oil as well. This study was undertaken at a European level, so here we considered the EU 27 group of countries, as well as the UK at the time, and considered both scenarios for 2030 as well as 2050. And here we followed quite a top-down approach, where we looked at the overall availability of biomass resources, and then thereafter looked at current bio-based product usage for these products, and thereafter looked at the overall requirements for bioenergy, considering the different sectors, power, industry, residential, and then lastly, what would be left over then for transportation. As part of this analysis, of course, there are a number of different assumptions that were utilized, and in order to crystallize this, we evaluated different scenarios for future biomass availability. So these were the low, medium, and high scenarios. The low scenario considered biomass mobilization at 2020 levels, so considering farming, agricultural and forestry management practices at baseline levels. And thereafter, in the medium scenario, we considered the opportunities in terms of increased mobilization of biomass resources by looking at increased mobilization in specific countries that have high biomass availability. And then lastly, in the high scenario, we considered further improvements in terms of farming as well as forestry practices, improved research and development in all of the European countries, and this, of course, results in a much higher biomass availability to 2050. What I'd like to share with you on the next slide is just the results of this study, and this is to give you an indication of where do the different biomass resources lie in the EU. So on the slide, you will see the different scenarios that we considered. Again, the low, medium, and high scenario for 2030 and 2050. And here you can see the distribution of biomass resources. The largest resources, of course, as you'd expect, are in the agricultural and forestry sectors, where we see a high proportion in terms of the potential for energy crops. And maybe to mention here, as part of our work, we evaluated only the production of energy crops based on cellulosic feedstocks on land that is considered unused, degraded, or abandoned. In addition, you'll also see here forestry biomass being quite high, primarily looking at stemwood, primary, and secondary forest residues. And what you can see here also is that biowaste also contribute quite marginally towards the total availability, with the majority of the availability, as indicated, being in forestry and agricultural resources. When we consider then the biomass that's available for bioenergy, so here subtracting the biomass that would be already being used for existing bio-based products, the availability in terms of millions of tons of oil equivalent for 2030 is approximately 208 to 344, which then increases marginally to 2050 to 215 to 366 million tons of oil equivalent. There we go. So here, now taking the basis of the total amount of biomass resources that is available in terms of overall bioenergy requirements, we then consider what are the needs of the other sectors that are using these biomass resources. So here, we considered the report by the European Commission, which indicated the use of biomass for power, industry, and residential sectors of approximately 170 million tons of oil equivalent. So based on this, we were able to then extrapolate the results and then consider what would be the biomass that would be available specifically for the production of sustainable biofuels. So here, looking at the best available technologies to be able to convert these biomass resources and then assess what would be the amount of biofuels that would be produced. And so what you'll see on the slide here is just the biomass converted then to final biofuels production for the three scenarios for 2030 and 2050. And here you can see the potential availability. And I think here it's important to highlight the potential portion here is that these resources are not necessarily at these levels today, and there will be significant mobilization that will be required to be able to unlock the resources to be able to achieve these levels of biofuels in future. So as part of the study, we then evaluated the production of the biofuels with the potential availability of approximately 29 to 79 million tons of oil equivalent in 2030, which increases then to approximately 32 to 137 million tons of oil equivalent by 2050. Great. So here I'd just like to also then take a broader perspective, comparing some of the other recent scientific studies that were undertaken in this space. Maybe just to start off with, I'd like to highlight an important study that we are currently still ongoing with, which was being undertaken with Utrecht University as well as TNO, where we are looking at biomass availability in the EU again, but here looking at a much more granular approach. So here, the intention is not only to determine biomass availability, but also understand the supply chains that are associated with biofuels production as well. So as part of this study, we looked at a more granular level at biomass resources, specifically using a spatial-based model to assess agricultural residues and understand the distribution of those resources at a regional rather than a country level that was undertaken in the previous study. So this study is being undertaken currently, and we expect to publish this later this year. I'd like to just maybe give you a snapshot of some of the results of the study, so you get an indication of the type of results that we're able to produce here. As indicated, we're able to map the agricultural feedstocks at quite a high level of granularity, and here you can see just an indication of energy crops, cereal straw, and maize stover up to 2050, where you can see the distribution of resources across the EU. As you would expect, energy crops are primarily, the potential is primarily in Southern Europe, which incidentally is, of course, the region where we see the highest amount of water stress. So here the key takeaway is, as much as energy crops could be produced in these areas, there's a need to also account for the impact in terms of water usage as well. In terms of cereal, straw, and maize stover, you can see these are also traditionally based in the areas, of course, where cereal and maize is traditionally being cultivated as well. Just looking at some of the recent studies that have been evaluating biomass potentials, here I'd just like to highlight a couple of studies. I've mentioned already the Imperial College studies of 2021, the Utrecht and TNO study, which is still ongoing, which we published later this year, and then the recent study that was undertaken by DGRTD, the drop-in fuel study, was published in 2024. This is quite an important study as it also includes the new feedstocks as part of Annex 9, which are the crops grown on severely degraded land, as well as the interseasonal or cover crops as well. And then two earlier studies here for completeness as well as also the DGRTD study of 2017 and the earlier study undertaken by the JRC in 2015 as well. And what you can see here, of course, is that there's quite a big spread in terms of the results. And this, however, is primarily related to the assumptions that are utilized for the different studies. So the different studies use different assumptions regarding yield improvements over time, different assumptions regarding the amount of land that is available, and this results in the spread that you see in the results. However, what's clear from the results is that in general, from an order of magnitude perspective, you see that there is close agreement in terms of the studies, in terms of overall amounts of biomass that's available, given the nuances of the different study that I've mentioned. And also you can see, again, that there's a clear indication of the role of agricultural and forestry biomass resources that are contributing quite a lot in terms of the overall availability. Okay. Of course, one of the next questions to ask is, what is the future outlook in terms of fuel demand as well? And how does this translate into the biomass resources that are available, and whether those will be really enough to meet the future demand? Florence mentioned a bit about the different needs for the different sectors. As aviation and maritime transitions, what will be the need of these different sectors, and how do we foresee this? So there was a study that we've also recently published. You can check it out on our website, looking at 2050 scenarios for Europe for decarbonization. This was a study that we'd commissioned with S&P Global Commodity Insights. The full report's available on our website, as I mentioned. And this specifically looked at what would be required to be able to meet the net zero targets of 2050. So looking at the role of both electrification and low carbon fuels. And here we considered two bespoke scenarios that were developed by S&P. The first scenario we called a max electron scenario, and here we looked at unprecedented levels of electrification across the road transport sector, specifically meeting the Fit for 55 targets, as well as the light duty and heavy duty targets, as well as some level of electrification in terms of passenger, in terms of aviation as well as maritime. The more molecule scenario here was a contrasting scenario which was derived from the max electron scenario, which considered a lower level of electrification complemented by the increased use of low carbon fuels. Here, we did not consider the partial electrification of aviation and maritime till after 2050 and considered then an increased use of low carbon fuels being primarily sustainable biofuels and e-fuels in this scenario. What's of course important to mention here is, of course, these are not forecasts of the future, but really to say that these were two scenarios that we looked at to consider what could be the potential need for biofuels as well as e-fuels in future. There are a number of different future scenarios that could be considered as well, which of course within the constraints of time we didn't look at. So just to give you an indication in terms of what the results of the study were, from the work we were able to understand what is the future demand for the different segments, so light and heavy duty transport, aviation and maritime, and based on that determine the requirement for fossil fuels, e-fuels, as well as biofuels. Okay. So the next slide here just shows you what is the forecasted, or let's say the predicted requirements in terms of biofuels going forward. Here you can see a projection from 2024 up to 2050 for the two scenarios, the max electron on the left and then the more molecule scenario on the right. And what you can see here, of course, is that as the targets for decarbonization increase quite steeply, the requirement for biofuels increases quite steeply as well. Here we map the demand for biofuels against those theoretical maximum potentials, which I showed you in the earlier slides for 2030 and 2050, approximately 79 million tons of oil equivalent by 2030, and 79 by 2030, and approximately 140 by 2050. And what you can see in both of the scenarios, as much as the requirement for biofuels increases, we do foresee that there will be sufficient potential availability up to 2050. And of course, here again, the point is that really this is a potential maximum availability, and there will be a number of different policy as well as strategic requirements to be able to unlock these resources. Maybe just to conclude with some key takeaways. First of all, just to highlight again that there is the potential for availability of sustainable biomass resources in the EU. According to our calculations, this is estimated to approximately 344 million tons of oil equivalent by 2030, which increases marginally to 366 by 2050. When we consider the needs of other energy sources, the remaining biomass potential can be converted to biofuels, and this results in approximately 79 up to around 138 million tons of oil equivalent up to 2050. As per the study we've undertaken with S&P, we foresee that this potential for biomass and sustainable biofuels will be sufficient to meet the demands of all of the sectors by 2050, considering the scenarios that we evaluated. To highlight the feedstocks again that contribute towards the availability, as I mentioned, low-grade stemwood, forestry residues, as well as agricultural residues and energy crops. Further, I think it's important to mention that as much as there's a potential for availability of biomass resources in future, there's a need to be able to develop the required supply chains to be able to unlock these resources. Of course, these resources are widely distributed and quite heterogeneous across the different regions, and therefore it's important to understand how to unlock these resources across the EU. And then lastly, just to indicate again that there have been a number of different studies that looked at biomass availability, and we foresee that there's quite a high level of congruence between the different studies, given the different hypotheses that they looked at in terms of mobilization of biomass resources. So with that, I'd like to say thank you and open up for any questions or comments from the audience.
Thank you, Abinash. Are there some questions in the audience? No?
Hi, Abinash. Just wondered if you addressed biodiversity needs. I know it's a question that comes up. Was that part of the study? Is there anything you can say on how you addressed that?
Yes, sure. So in terms of the feedstocks that we evaluated, one of the key requirements was that we needed to consider the impact in terms of biodiversity. So in terms of the specific feedstocks, we excluded land that was considered of high biodiversity value. You'll see the feedstocks that were considered here were specifically ones that we foresee that there isn't any impact in terms of biodiversity. And as part of the yield improvements that we considered as well for both agricultural as well as forestry, we also considered practices that are in line with sustainable practices to avoid impacts in terms of biodiversity. So I think, of course, one of the key questions that we often see arising is indirect land use change. So of course, this is something to consider as well. So you'll see again, as part of the feedstocks that we considered, the impact in terms of land use was quite strongly considered. And of course, here we of course follow the risk-based approach in terms of indirect land use change and only consider the feedstocks that were considered in, of course, RED 3, Annex 9A as well as Annex 9B.
Yeah, Sylvain Demour from Bioethanol France. My question is about the limitations in terms of when you talk about availability. There is the owners of this biomass. Did you evaluate the willingness to put on the market that biomass? First point, and did you take into account the cost of mobilizing that biomass, which can be very, very different depending on the biomass you consider?
Sure. Okay, I will answer the second question, which is a bit easier. So to look at the cost to mobilize the biomass resources, this is part of the current work that I mentioned that we're undertaking with Utrecht and TNO, where we're specifically developing a model that evaluates the overall supply chain cost for biofuels. So considering both the the farm gate, so to say, looking at the transportation aspect as well as the processing of the biomass. So here we're able to look at the biomass resources across the EU and be able to look at how much it would cost to mobilize those resources across the EU. So I hope to actually present this work later this year or perhaps in this forum again to be able to show you exactly to answer your question in a quantitative way, how much it will take to mobilize those resources in different sources. To your first question regarding willingness, of course, that was something that we did not specifically look at, but I think it is an important aspect to consider. What would be the potential business models that would need to be developed to be able to unlock those resources, and what would be the necessary policy aspects that need to be considered to be able to encourage farmers and create incentives for them to do so.
Thank you very much. Unless you have a very... Oh, yes, Anne, last question.
Thank you, Abinash, for the great presentation. And Bouter, European Commission, Jersey. I was wondering, in the first slides, you presented from the study from Imperial College. For the three scenarios, did you consider also the environmental impact, for example, for the medium and high scenario? Because you say that the yields will increase. So I'm wondering if you increase the yield, then you will increase the amount of fertilizers. And if you have some figures in mind, or if you intend to perform maybe a follow-up study.
Yeah, I think that's a very important question. I think I alluded to a little bit in the previous comment as well, where you'll see that as part of the yield improvements that we considered in the study, they're actually quite modest. Approximately less than 1% per year. Of course, that accumulates over a number of years. But as part of that, we considered a minimization in terms of the impact in terms of the environment. So here would be minimization of the use of fertilizers, the use of pesticides, as well as more sustainable, as well as more precision-based farming practices as well. So this results in that the yield improvements are not as significant as you could expect when you obviously maximize the use of these fertilizers, etc. But we consider that this to be a more sustainable approach rather than to push yields at the detriment of the environment as well. Of course, this requires a lot more further evaluation as well. I mentioned a little bit about the crops grown on severely degraded land and the interseasonal crops as well. So we are currently undertaking a study at the moment where we'll look at this in more detail to understand what the impacts will be.